Now that we've been looking at ellipses and we know some different things about them, we want to start writing equations for you, be able to write an equation for an ellipse. So this is just, again, a reminder of the notes that you took on ellipses. So I'm going to kind of skip over this. If you want to pause the video and read through it, please do. I will reference it from time to time, but I'm going to go ahead and jump right into example 1. There are 3 examples. They are all slightly different, so please do make sure that you stay checked in for all 3 of them. On the first one, I'm going to write an equation of an ellipse, and I'm given information about my major axis and my minor axis. So I'm pretty visual, so I would graph this out. I don't necessarily need graph paper for it. But let's see, my major axis, my longer axis, goes from -6 to 2, and I'm actually going to go ahead, and when I graph it out, I'm not even going to use an XY plane. I'm just going to go ahead and say that I would go back 6 and up 2, and then I would go back 6 and down 8, and then I'm going to say for my minor axis I would go back 3 and down 3, so maybe somewhere like here, and back 9 and down 3, so maybe somewhere like here. So my ellipse should look something like this. Well, I can already see that it's vertically stretched, so I'm going to go ahead and make sure that y is over my a and x is over my b, so I'm taking this formula here. So I'm going to go ahead and say I'm going to use the form x minus h squared over b squared plus y minus k squared over a squared equals 1. So now I have to go ahead and figure out what A and B are. Well, I also have to figure out what my center is. So my center should be right in here. Well, notice that it lines up with my minor axis. So if they're in line together, they must have the same y-axis, y value. So I must have a y value of -3. I notice I'm also in line here. So these are all on the same vertical line, meaning they all have the same x-axis. Well, my major axis has x values of -6, so my center must be -6, -3. And then if I can find this distance, that's going to be my A, and this distance here is going to be my B. Well, how do I go from -6 up to 2? Because remember, this point here was -6, 2. So how do I go from -6, -3 up to -6, -2? Well, I would go up 3 spaces plus 2 more, so I can go ahead and say my A is a distance of 5. Remember that this point here is the point -3, -3. So again, when determining B, I can say, how do I get from -6, -3 to -3, -3? Well, it must be a distance or a space of 3 units between -6 and -3. I can also find distance by subtracting and taking the absolute value. So for example, this 5 here, if I said what is 2 minus a -3, what is the absolute value of that? That gives me my 5. Or if I had said what is -6 minus the absolute value of -3, that would have given me 3. So you can either determine it from kind of counting your spaces on your diagram, or absolute value means distance, so you can also use that. Either way, once I have my A, my B, and my center, my center's here, I can go ahead and plug those into my equation. So I'm going to have x minus my h, and my h was -6, so I'll have plus 6 squared over b, which was 3, so 3 squared is 9, plus y minus my k, well my k was -3, so I'm going to go ahead and say plus 3 squared all over my a squared equals 1, and that's going to be my equation of my ellipse. Moving on to the next one. So slightly different, so now I'm given my vertices and my foci. Remember, my vertices are the endpoint of my major axis, so again, if I sketch this out, let's see, I'm going to go back to -4, up 4, up to 6, up 4. So again, I know that's my major axis because they're my vertices. If it was my minor axis, they would be my co-vertices. So it's going to look something like this. And then I also have my 2 foci at -2, 4 and at 4, 4. So again, I can tell by its orientation which equation I'm going to use. So I want my x over my a this time. Oops, not plus x minus h. And then my y would by default be over my b. It's equal to 1. So again, I have to figure out what a, b, h, and k are. So I can find my center, because my center is going to be the midpoint of this line here. However, I can go ahead and say that because my center falls on the same horizontal line as my vertices, it's going to have the same y-axis of my vertices. So I'm going to go ahead and say my center is at h, 4, and h is going to be my midpoint. So I'll go ahead and label. So this was -4, 4. This was 6, 4. And my midpoint formula says add the two values together and divide them by 2. So I'm going to go ahead and take my two x values, since that's what I'm trying to find. -4 plus 6 divided by 2 gives me 2 over 2, which is 1. So now I know my hk. My hk is 1, 4. Well, now I have to find my a and my b. Remember, a is the distance from the center to the endpoint on my major axis. Well, now that I know that this point here is 1, 4, I can either use absolute value, or I can say, how many spaces have I moved to go from 1 to 6? Well, I've moved a distance of 5, so I can go ahead and say that a is 5. And now I have to find b. I'm not given enough information to just pull b out of this diagram. However, I am given some information about my foci, and I know that my foci is the distance from, or c, excuse me, is the distance from the center to my focus. So I can say, what is this distance here? Well, remember, this is at -2, 4. So my distance from 1 back to -2 is going to be my c value. So my c value is a distance of 3. The reason that's important is because if you look above in your notes, we have a formula that puts a, b, and c together. It tells us that a squared minus b squared equals c squared. So my a I decided was 5. I don't know my b squared, and my c is 3. So I will get -b squared equals 9 minus 25. So -b squared equals -16, which tells me that b squared must be 16. So now I have everything I need. I have my center I can put in for h and k. I have my a, and I have my b, or my b squared. So I'm going to plug all that in. And I'm going to get x minus my h, which was 1, plus y minus my 4. And I'm going to put x minus 1 squared over a squared, and y minus 4 squared over b squared. And there's my equation. So looking at one final example. Again, I'm going to go ahead and draw this out because, again, I'm visual. So I'm told that I have vertices at -2, -4, and -2, -9. So back 2, down 4. Oops. Back 2, down 9. And because they're my vertices, I know that's my major axis. Okay? And the length of my minor axis is 10. Okay. Okay, so if the length of my minor axis is 10, I can right away assume that my b is half of that, so my b is going to be 5. My a is going to be the distance from the center down to my major axis. So I'm going to go ahead and find my center. Well, since these lie on the same line, I can go ahead and say they're on a vertical line, so they share an x-axis, or an x value of -2. I can find the y value by taking the midpoint again. So my y value, my k value, is going to be the midpoint. So again, I add these two together. -9 plus -4, divide by 2. That gives me -35 13 over 2, or I could say negative 6.5. Okay, so that's going to be my y value. So now the distance to find my a between negative 6.5 and negative 9, I would say is 2.5 units. So I'm going to go ahead and say my a is 2.5. And the reason this isn't making sense is because I'm looking at my work, and this was supposed to be a 9, not a negative 9. So I'm going to go ahead and just stop this example rather than try to change all of it, because it's not going to work, and I'll just have you follow the top two examples as examples to use when completing your work.